Hello, my name is Liz Schlemer, and this is a video for IME 443, Facilities Planning and Design at Cal Poly San Luis Obispo. This video is on make versus buy. So again, we always are talking about excellent engineering within the context of the culture or the project that you're working on. And this particular video will talk a bunch about how to specify the primary and support activities as the second step in the systematic approach. So in this make versus buy decision, the question is, do we have to design an area to make this particular portion of the product, or are we going to get it from a supplier? And in that case, there may be some space requirements for the inventory, etc. So again, the whole process of facilities design is broken up into several portions, and right now we're looking at the layout design, as many of these videos do. So in a make versus buy analysis, there's really kind of three steps. You first clearly think through what are the alternatives of make versus buy and what are the consequences of each of those alternatives. Then you perform economic analysis to compare that using engineering economy, and then you think through strategic and qualitative issues associated with the make versus buy decision. And we will go through all of these three steps in this video. So when you're considering making this or that or buying that, what in our operations would be different? That's the question we're asking in this first step. The economic analysis also would include initial costs. Are there one-time costs at time zero, or are there ongoing costs every month or every year? So if we look at this particular product here on the right and we decided to make it, what are all the things that might be considered? And here are just several sort of brainstorming issues. Do we need to buy machines? We need to buy molds. We need space in our factory. We might even need to have a place to store molds. Do we need another operator? Do we have to store the inventory itself, the raw material and the work in process? We have to purchase raw materials, so we might have to have a purchasing person involved. We might have quality inspection in the process. Maintenance costs. Do we need another supervisor? Is this process something where we might have to add some other kind of overhead like insurance? And then if we bought it, what are all the ongoing costs associated with that? Do we have to store the inventory, the items we're purchasing? Do we need another shipping operator? Is there going to be quality inspection when things arrive? Do we need another person in purchasing because we're going to be purchasing more volumes of things? And again, the overhead aspects of, do we need a supervisor or do we need higher insurance? So as an example, if we make something, the machines that we're going to think through as, will we have to do research on the type? We will have to do research on the type and cost of the machines that can handle our required volume. We need to document initial costs, including installation and ongoing maintenance cost of this machine. We also need to note the footprint necessary, etc., etc. If we're going to buy something, we want to think through supplier quality management. The purchasing or supply department might have to manage another account. Well, we want to talk to them about the differences in managing an account for this kind of part versus the work that they manage for raw materials. If there's a difference, we will need to convert that to ongoing cost. So possibly include increase in hours, time in the purchasing department. And this should all be documented. So you can see this is an extensive conversation. This is just two examples of the things we need to think about in the make versus buy decision. So now once we have explored all the costs associated with this, we use engineering economy to evaluate the two alternatives. So I have created a simple kind of spreadsheet that documents both the make and the buy alternatives. So if we make it, we'll have to have machinery, training, installation. So we have initial costs. We also have ongoing costs, a new production supervisor, raw material, electricity, maintenance, other overhead, insurance, rent. So I've laid out the particular cost in a time series. I've decided to analyze this over 5 years. Now we look at the buying. There's going to be training associated with buying too, but we also are going to have the cost of purchasing the items. So instead of the raw material and the labor costs of making it, we're going to have the cost of purchasing it. We also have a cost of holding inventory and possibly more space in the warehouse, so we'll need to have higher rents. So I've laid out all these costs, both initial and ongoing costs. And then I've kind of put it in an engineering economy process. So making would be an initial cost and then ongoing costs. Buying would be a smaller initial cost, but bigger ongoing costs. And the way in engineering economy you do this is you actually do an analysis of make versus buy. So the concept here is if I make it, I'll have to increase my initial costs, but I will have payback associated with the savings of not buying it. So now this becomes a way that we can either calculate internal rate of return or net present value. And if you're doing this and you need to decide, well, what is our minimum attractive rate of return, if you remember that from engineering economy, and you'll have to figure this out too. Lots of times companies have this specified. And then if the make versus buy analysis, if the NPV is greater than 0, then that means it's a good investment to make the product. So now we've gone through this, thinking clearly through it. We've done different economic analysis, and it looks like it's a good economic decision. So what are the other qualitative issues that we need to be concerned about? What is the strategic direction of our company? And here's some examples of questions. Is this in our area of expertise? Is this an area we would like to grow into? Do we have the in-house capabilities in our workforce? Do we think we can do quality control better in-house? How fast can we implement this? Do we have the space? Why would we give up the profit on this process? Do we have existing unused capacity? And then in the buy alternative, we want to say, can the suppliers respond quickly to our changing needs in an engineering change request or a manufacturing change request? ECR, MCR. Is the supplier a stable firm? Are there multiple suppliers available? So you can see there's a bunch of questions we need to ask associated with this before we make the final decision.